Okay, let's start for today. So last time we talked about inheritance, and today we'll continue talking about the same subject, but from a slightly different perspective. So we did talk about subclassing. Today we're going to be looking at interfaces and generic types, and how generic types and subtyping can be combined together, but also how can they not be combined together, and things we have to be careful about. So if you remember what an interface is, so an interface looks very much like a class, but instead of defined as a class, we define it as an interface. But also more importantly, when we define an interface, well, we give its name, and then we give its methods. But we only give them the headers of the methods. We don't give the implementation. So in contrast to classes, with interfaces, we only have the headers of the methods. And then when you have classes extending, which actually is called implementing, so you have classes implementing an interface, so subtyping an interface, then at that point the class should provide the implementation of the methods of the interface. So if you like, an interface is a general type that contains the methods, and then the classes that implement the interface actually give also the code. For instance, we can have, well, we talked about, we have an example interface. This is called priced object. So what is a priced object? Well, it is an object upon which you can call a getPrice method, and this gives you back a price, an integer. So you can refer to any object with a getPrice method, And for example, we had seen that well, the drinks machine class that we defined from the first lecture already implements this priced object because it has a get priced method. So we could declare a drinks machine as implementing priced object. But also you can have other things that are priced object. For instance, a Scrabble word. So a word from the game Scrabble has a price, which you can get by just adding the scores of all of its letters, and this gives you a number. You can say, okay, this is actually the price. So you can actually implement the priced object interface using a class Scrabble word. And not only that, but use of interfaces allows you to write generic code. So for instance, having these two classes here, which implement price object, I can write a method cheaper that takes as input two priced objects, M1 and M2, and returns the one that is cheaper. And well, obviously the way it works, it says, well, if the price of M1 is less than the price of M2, then return M1. Otherwise, return M2. What is interesting here is that, well, obviously since both of the classes implement the interface, you could, please give me a bit messy. You have a drinks machine. I don't know, M1, M2. You can have Scrabble word, W1, W2, and then you can call, I don't know, cheaper M1, M2, or you could call cheaper W1, W2, or you could even call cheaper, I don't know, on M1, W1. So why would this type check? Maybe I should do something with the lights. Maybe it's a bit better. So why would this type check here? Well, because this method here, cheaper, expects a priced object, M1 and M2. If you give it to drinks machine as inputs, well, since drinks machine is a subtype of price object, this is okay. You can do that. So you can pass an object of a subtype where a type is expected. And the same from W1 and W2, and the same from M1 and W1. So we can see that using interfaces we can run generic code. And also in cases like these where notice that since the interface does not implement its methods, then the actual classes that implement the interface can have very different code for the same method. So then the code that you write that is generic on interfaces will call upon these methods, and they can have very different behaviors. Because to start with, you define a method on an interface, and the interface has a method. I mean, the method that you're calling the interface on is not implemented yet. Anyway, so that was our example. So what are the rules, the basic rules for using interfaces? Well, we already said an interface only contains method headers, and then a class implements an interface and gives the body, or like implementation of these methods. And then on the other hand, while in Java a class can only extend one other class, it can implement any number of interfaces. And the idea is that since interfaces don't have code for the methods, you can extend different interfaces with the same methods, and that is fine because there's no clash in a sense. I mean, you don't have code for this method, so the class is going to give the code, so it's fine to implement several interfaces. So this is therefore the second way we have seen for subtyping in Java. So one way of subtyping was using the subclass mechanism, the second one using interfaces and implementation of interfaces. Any questions? Okay. Now, if we go back to this, to our example, so we had priced object and we had drinks machines. So what about the following? So we have this interface priced object and we have this getPrice method. So what about writing a method that you give it now an array list of priced objects and it computes the one that is most expensive and returns you that object. So I could write this as follows. So I can write public static so this will take say most expensive. So my method will take an array list of priced object. Not much space. Okay. And return the most expensive. So, okay, how can I implement this? I can say, let's suppose that my array list is not empty. If it's empty, my code is going to break, but it's fine for now. Let's say highest equals a get 0. So this is the highest so far, and then I go in a for loop. And I say, well, if highest get price is less than the price of the ith element, then set highest to be the ith element, and then return the highest. Okay, so I have this is just a linear search on my array list. I start from the beginning, then I have this variable highest, and I remember the one that had the highest price so far, and as I go in my linear search, whenever I find someone who is bigger, I update my highest by saying, okay, let's update the highest to the ith element because the ith element is higher. And now the question is, if I write this method, then if I have an array list of priced object, a equal, okay, and then I add some elements. Then can I run most expensive on it? Okay, here I just run most expensive and I throw it away. The answer is that yes, this will work because, well, it's obviously well typed. Here you have to think what are you going to add in the priced object. And you can add both drinks machines and Scrabble words, for instance. And this will compile. So even if I have here a.add new drinks machine, this will work. And it works because, okay, you have this priced object array list and fine. Now the question is the following. So we have seen that drinks machines is a subtype of priced object. Then can I say here, well, so this word, can I say, well, define an array list of drinks machine be equal, and then run most expensive on B. So surely drinks machines are priced objects, so array list of drinks machines should be priced objects, so should this compile? So the question is, does this compile? And I mean, obviously the same code that we wrote here should work with a priced object, with a drinks machine. You just go here, instead of having priced objects, you have drinks machine, so it should, I mean, logically speaking, it should work. Oh, that's actually what one would think. But the answer is no. So we have to be very careful with subtyping and generic types, and type constructors. So the fact that drinks machine is a subtype of priced object doesn't mean that the array list of drinks machines is a subtype of array list of type of priced object. So this is not the case. It is not allowed in Java. So this code here wouldn't compile. And there is a good reason for that, and the reason for that is that the logic is saying that, well, if alpha is a subtype, in general a subclass of beta, then array list of alpha should be a subclass of beta, is false. And to see a concrete example, if I have a class beta that extends a class or implements an interface alpha, this does not mean that the array list of betas subclass is the array list of alphas. Because if that was the case, for instance, I could write the following code. I start with an array list of priced object A. And I'll say, okay, since drinks machine is a subclass of priced object, so let's write this for subclass, then the whole array listing should be a subclass of that. So now I'm assigning to A, which is of this type, a new object of that type. This is a subclass, so that's fine, so this should pass. So now I have A, which I have declared as an array list of priced objects, to actually be in an array list of drinks machines. And then I can say, okay, here's a new Scrabble word. Scrabble word is also a subclass of priced object. Well, it implements priced object. So, I mean, this guy is expecting to add a priced object. I add a Scrabble word, so it should work. And now my code is broken because I have a priced object, an array list of priced objects, which I'm trying to add Scrabble words. So if the compiler would allow us to compile this code, we would compile, we would run it, and then it would break because you have an array list of this. So you have this A, which has actual type, this one, and then you start adding to this Scrabble words, which are of a different type. So in a sense, what we're doing in this way is that well, we're mixing a bit apples and oranges. So the underlying reason this doesn't work is that in an array list of priced object, one can add priced objects by calling add, and then this means that you can add both drinks machine and Scrabble words. So if you have an array list of this type, you can add drinks machine and Scrabble words. So it better be that your array list cannot have actual type to be an array list of either drinks machines of Scrabble words, because then you have committed yourself to one type and then you add things of the other type. So put otherwise, A is a mixed array list, so you cannot start it with concrete array list of one of the two things. Okay. A more general rule, a more general reason why this doesn't work is that, well, there's no reason that if you have one class being a subclass of another, that if you put it in an array, in a type constructor, then the overall type is a subtype of the other one. There's no reason that this logic should hold. Okay. But now coming back to my code, so are there any questions on this? Okay, so coming back to my code, I had this most expensive, so we said, okay, this doesn't compile. But I have this piece of code. So this piece of code will work if I call it on an array list of priced objects. But now the question is, okay, I cannot actually call it on array list of drinks machines. So how can I change it so it becomes generic in this way? So it becomes generic in the sense that I can actually call the same code not only on array list of price objects, but also on array list of drinks machines and Scrabble words. And we cannot do it as it is. So we said Java will not allow us to compile. But there is another mechanism to do it, which is by using type variables. And this can be done as follows. So let's look at the code that I have here. So I have the same code as before, but instead of saying that the method expects an array list of priced objects, I say it expects an array list of t's. And what is t? Well, t is a type variable. And in particular, is a type variable that extends priced objects. So basically, I can call this method on an array list of things where the things are of type that is a subtype of priced objects. So I can call it on drinks machines and Scrabble words. And then I have the same code as before. The only change I made was this. So instead of saying that this will create a priced object, it will return a t. And the overall method will return a t, which is, well, the generic type I defined there. So this is very much like what we had seen before with writing generic methods, where you have just t here. You say, okay, t is a type variable, and this is my generic method. But actually, in this case, is a type variable that is bound above. So whatever you give as t, it better be that t, in the subtype hierarchy, is below priced object. By these arrows, I mean that this guy is below this one. In particular case, it implements this guy, because priced object is an interface. So t must implement priced object. And the rest of the code is the same. And why does this code compile? Well, because we have defined t to be a subclass of priced object. So we can set it well, either on drinks machines or on Scrabble words. Okay, that is what is going to work on drinks machines and Scrabble words. The reason why the code compiles is, well, we said that this extends priced object. So in particular, where we say that here we call the getPrice method on these things, well, this and that are of type t. Type t implements the interface priced objects, so therefore it must be that these objects have the method getPrice, so you can actually call them. Okay, yep. Yeah. Yes. Yeah, so, yeah, that's true. You would expect maybe here to write implements, but yeah, Java allows you to write extends in the sense that you extend the type. Yeah. Yeah, yeah. Actually, let's look at a demo. Maybe it's a good idea to start straight away. So I have my demo here. So there is demo 1. Let's see whether I can make this compile. This is my terminal. That's too large. Okay, so let's see. So if I go here, what I have an interface gamma, and it has one method called foo. And then I have delta, which implements gamma, and then it has a private variable, val. And basically, when you call it with the constructor, you give it a number, it stores the number. So when you call foo, it returns this number. So this is the same as a price, it's just the price is fixed. And just to make the method shorter, I say foo instead of get price. On the other hand, delta 2, it again implements gamma, but it doesn't have, you cannot give it a different price. The price is fixed, so when you call foo, you get back 42. So delta implements the interface, and it allows you to set the value, its price, its foo, when you call it, when you construct it. Delta 2 is fixed to 42. So here I have some methods. So let's look at the first one. So the first one is implementing this. So I want to find, so I have, if I given two elements of type gamma, which one has less foo? So basically I call foo on both, and I return the one with the smaller price, the smaller number. And then I have a less foo 2 when I now have written my code as before. I have, say, t extends gamma, and then I do the same thing. And okay, let's see this too. So if I run them, so it allows me to compile, and then actually if we look at what I did with less foo, I basically called less foo on two objects. The first one was a delta with number value 43, and the second one was a D2. We said if you call it a delta 2, it has number 42. So when you check for the less foo, it will tell you what the less foo is the delta 2. Okay, here I was a bit naughty because I printed objects without actually being very, without implementing printing myself. So I let Java print them, and then Java just prints well, the reference to the object. So I can understand which object it is by just looking at what class it is. So it's delta 2 and delta 2. So coming back to your question, yes, although gamma is an interface, I can say t extends gamma, and that's how it will allow me to make this work. Okay. Now, so that was the first example of generic types, sorry, of bounded generic types. Now there is an extra mechanism I can use, and this is the following. So I had this code here, and I can see that here I have the t here, so the t that is returned and the t that I have inside the body. But I can replace this t with priced object. I mean, in the end, I know that this t is going to be extended priced object, so I can just say, okay, this is actually a priced object. And if I do that, I have the code here. So the code inside the method will be the same as before. But what can I see is that this type t is never actually used in my code. I mean, it's used here, but that is just used to specify the signature of the method. So Java allows me then to anonymize t altogether and say, instead of having this big header, I can say, okay, I will return a priced object, and the input is going to be an array list of things of type or well, of any type that extends priced object. So this t here, this used to be t before, has been anonymized to a question mark. And since the t is not used in my body anymore, in the body of my method, or in any other place in the header of the method, I can actually anonymize it and make my code shorter. And then the rest of the code remains the same as here. So I say, okay, the array list is of some types which extends priced object, and then the code is the same. Okay. So this is another mechanism that we have for bounded types. And I think I had in the demo, I had also something about this as well. Okay, and I have, yeah, in my demo I have implemented this most foo. So if we go back to the demo, so I have this most foo methods, and I have implemented in different ways. So the first most foo is the one that we saw before. So you have t extends gamma, and well, you use t everywhere, and this returns the fooest. So the element of the array is with the highest foo. In the second case, you say, well, I don't care about returning t. Let's say that I return gamma. So here, and therefore you have gamma here. And in the third case, in the third version, I have anonymized t and say, okay, forget about t, just say that this is some type which extends gamma. So it's basically the three variations we saw so far in the notes. And then what does my code do? Well, let's see. It creates an array list of gammas. And now, since it's an array list of gammas, it can add deltas, because delta extends gamma. So it adds a delta with value 0, a delta with value 1, it adds a delta 2, and then it calls most foo on each of them. And then, so this, actually, if I run it, it will run this way, and it will say, okay, the fooest in this case is always delta 2, because remember it has the value 42, whereas these guys have value 1, 0, 1. So it works, but in this case, okay, this was already an array list of gammas, and so we kind of expected it to work. What if I make an array list of deltas, and then I add 2 delta elements and I call most foo on it? So I haven't printed anything. So let me print it here. Well, it wouldn't make much sense. Anyways. Okay, so then tell me, yeah, it's not very, I'm sorry, it's not very, actually, let me do that. Let's call foo to see what we get. So yeah, it will tell me that the foo is the one with 42. So what if instead of this one, I call most foo 2? So if I try to run this code, so remember the first code I wrote here, where is most foo? It had t, and it was returning an object of type t. So this worked, but now then I said, okay, I want to change the code and use this version where I return something of type gamma. And before I actually said that this is kind of the same code, but it's not exactly the same code because the compiler sees these two things differently. So in particular, when I call most foo 2, remember that this returns a gamma object. So then here the compiler says that you want something of type delta, but actually you give it something of type gamma, and it will complain. It will say, well, I don't like what you're trying to do, because you say, well, basically it says I cannot convert gamma to delta. Here it says a bit different way. It says there's no way I can make T conform in this, to this type. So then this brings us to the next item, which is, well, we said that returning type variables or anonymize them can be the same, but actually the implementation, well, they're doing the same thing, but actually they're treated slightly different by the compiler. So, coming back here, so in the case where I had the code which will return the type variable t, and I have most expensive, I can create an array list of drinks machines, call most expensive on the drinks machines, and now the compiler can see that, well, let's see, this method here will return something of type t, and the type t is the same as the type t you give it as an input. Here you gave me as an input a drinks machine, so therefore t is drinks machine, and therefore the compiler can see that this is well typed. So this will return a drinks machine and it's happy. On the other hand, if I give it this code, it will see that what it expects as output is a priced object. So it will definitely complain, because it will say, well, this method will return a priced object. Priced object is a supertype of drinks machine. So actually what you're trying to tell me is to downcast. I will complain, I don't want to downcast. So this is a subtlety when we use bound types. Okay. Any questions? Mm-hmm. And now, in the same way that we had generic classes, we can also have generic interfaces. And a particularly useful generic interface is the one called comparable T. And this is for classes where you have a way to compare its objects. In particular, the interface comparable says that, well, you must have a compare_to method that takes another item of the same class T, and returns an integer. And the integer is the result of the comparison. And this is needed, for instance, if you want to run a code that sorts, for instance, array lists of these things or lists of these things. And actually, Java itself has a sorting algorithm for collections using this comparable interface. So coming back to our example, we had Scrabble word, and we can actually compare Scrabble word objects, which is, well, we get the price and we compare the prices. So if you want to Scrabble words to be comparable, then basically you have to say that it implements comparable, and then inside the code, you just make sure you implement this method. And now the trick is that since the interface is generic, when you declare that your class implements it, you have to declare that it implements it with a specific base type for the variable t, and then the signature of the method should say, well, I implement compare to, and actually with this type signature. So you should use the same type. And then how are we supposed to implement compare to? Well, there is a logic behind it, and we better be following it, otherwise, well, it's not going to be very useful. And the logic is that object 1 compared to object 2, so if object 1 is of a class that implements compare to, then if you call it on 2 objects, you should get a negative integer if object 1 is less than object 2, positive integer if object 1 is greater than object 2, and 0 if they're equal. And now how you define less than, greater than, and equal is up to you. So you're the one defining the class, you know how you want them to be compared, your elements to be compared. So you should define the logic of how compare to should work. So long as this logic is kind of consistent. So for instance, if object 1 compared to object 2 is negative, then it better be that if I call object 2 compared to object 1 is positive and so on. But it's up to you. Incidentally, this is called the natural ordering of the class, and that's because it comes with the class definition. So for instance, in the notes we have an implementation of Scrabble word where it has a natural ordering, and this is just, you take the word, you count all the scores for its letter in the word, and then this is the number on which you compare your words. Okay. And then if we have this, so if we have that the class implements comparable, then we can write code that actually uses this comparable interface, for instance, in order to sort. For instance, we can write a generic sort method for array lists, so long as we know that the array lists are of a type that is comparable. And the way we do this is, well, we add this statement in the signature of the method. So we say, again, we're going to be using a type variable, and it's going to be bound by comparable. So I have this sort method. As before, it takes an array list of t's, and then it better be that t's are implementing comparable. And then in the body of my method, using this fact, that t extends comparable, I can call the compares to method on objects of type t. So if I go, for example, I can write a selection sort, and this, so selection sort, you have an array list of elements, and then for each one of them, like for starting from the first element and going up to the first position and going up to the last one, you find who is which is the position that has the minimum element. You bring it back at the beginning, and then you go to the next position, and then you always bring back the minimum element, so in the end you get a sorted array list. So in particular here, I have that A is an array list of t's, and t extends comparable. So in particular, I can say A get I dot compare to, because, well, since t extends comparable, it has the compare to method, and A is just an array list of objects of this type. Okay. Okay. And actually, in Java, you have a method with this kind of signature. So if you go to the collections library, there is a method for sorting that has a very similar signature to the one we saw before. It said, here is my sort method. It works on lists of type T. Now remember that list, so list is an interface that is above array list, but it works also with array lists. And what is T? Well, T extends comparable, but here I didn't put T here. I say it extends comparable of a type, question mark, which is a supertype of T. So what does this mean? It means that T is some class, is some type, which is comparable either because you define compare to on it, on this class, or because you define compare to on a superclass of it, which is also comparable. So it inherited the compare to method from a superclass. And this is necessary because you might have, your class extends another class that already has compare to implement. You don't want to implement again, but you want to be able to sort. So Java allows you to say that by using the super. So if you see here, super and extends have opposite meanings. So extends means this guy is a subclass of this guy, whereas super says that actually this guy is a superclass of that guy. So you have two different ways to bound types. So we have super and extends. Okay, so coming back to bounded types and how do we define them, so we have extends and super in order to bound type variables. So when we add this in the signature, it means that T is a subclass of thing. So it can be this class, this type, or something that is below it. So if you like, thing binds T from above. Actually, this should not be binds, this should be bounds. It's a typo. On the other hand, when we say T is a super of thing, we say, well, T is either thing, is this type thing, or is something above it, is a superclass of it. And we can use combinations of these in order to get the desired relation between the type variables we have. For instance, here, we can define an add2 method that takes two array lists, a source and a sink. And what it does is it takes all the elements of the source and adds them to the sink. But, well, we can have them to be of the same type. But since we're going to be adding elements from the source to the sink, well, it just suffices that the source, the elements that it has, are of a type that are a subtype of the sink. So for instance, if this was of type object, here any type of things in source could be added. So we can say this by saying, okay, the source can be either T, the same as sink, or anything that extends it. So any subclass. And then the code is actually quite simple. It says, okay, you go through all the elements of the size, of the source, and you add them to the sink. Another way to specify this is saying, well, I want to say that the sink contains elements, the source contains elements of a type that is a subtype of the elements of the sink. This is the same as saying that, so sink has a type, source has another elements of one type, source has another type that is a subclass. But it's the same as saying that the sink has elements that are a superclass of the source. So obviously source and sink are opposite. So we can say that the source has type T, and the sink has type something that is a super of T. Incidentally, in this case, this is for any type T, so this is a generic method. We don't bound T, we just bound this type here of the source, or this type here of the sink. And then we're also lucky that this returns void, so we don't have to to be too careful of what type to return. Anyway, so these are the two methods of bounding type variables. So to sum up, to wrap up, what we have seen in last week's lecture and today's is that the Java type system is more complex than saying that, oh, each object has a type, and this is, well, it's given by when you actually declare a variable of a type and then you initiate it with an object, or when you create the object. So an object can have several types. It has a class where its constructor is in. It also has any classes or interface it extends, directly and indirectly. And on the other hand, an object can sit on inside a variable, and the variable can have an apparent type which is actually different from the type of the object. And then to make things a bit more complicated, again, you have generic types, which in general of this type, of this form, you have the base type inside a type constructor, gen type. And then we can write type that is generic in the base type. So we can write type that says, okay, let's say that the base type is T. But sometimes when we write our code, we want this t to have some properties. So in order to do that, we have to bound it above and say, in order to have this property, you have at least to be here. For instance, at least you have to at least be comparable, because we're going to use compare to on your objects. So the way we do this is by using body types and say, well, actually my t, I want it to extend some type with the properties that I want. And then also interfaces are another form of subtyping. We saw that also allows us to give us a lot of power to write generic code, but also we have to be very careful. And also when we combine subtyping, not only there are also some types with generic types, because subtyping does not pass through constructors, type constructors. But then we can overcome this problem by using generic types. And so I have a very last demo that is a very, well, actually a simple demonstration of how we can use comparable and how we can inherit comparable. So let's look at this as well. So I have this new, so I have this other file that has a class alpha that implements comparable, and then it has a private variable val that you set it when you call the constructor, and then compares to just says, you give me another alpha, and I return whether my val is greater than the other alpha's val. So I return val minus the other item's val. So this is the comparison. And I have beta and beta 2 that extend alpha, and they extend them in some silly reasons. They have the private variable, and then they do something with it. It is really not important. And then I have the sort, the selection sort that we saw before, that I'm not going to show you again. But then I want to run them. And now what I do is I create an array list of alphas and an array list of betas that is empty. It doesn't matter so much because, okay, that means that they're already sorted. What I want to show you is that, okay, this compiles and runs. But now what happens here is that the guy who actually implements comparable is alpha. So my class alpha has an implementation of compare to basically. Beta doesn't have it, it just inherits this from alpha. And the reason this works is that I say that the definition of the sorting method has, it actually wants me to have t which extends a comparable of some super of t. If I just put t here, and I said, oh, I just want t to be comparable because, well, t is comparable, it will say, well, actually not, because, yeah, because actually you want to do something that is comparable t, but actually your type is not comparable. Anyways, yeah, so that, do you have any questions? Okay, well then, thanks, see you on Friday. Very difficult.
It's actually quite essential to program.
Yeah. Yep.
We said that it's done like this. I want to ask, what if we just do interface comparable and write the T and make the method only generic? Will that work?
I don't think it will work because the signature of the comparable says T. So I would explain this. Yeah, I mean, wait a second, this doesn't work because actually you can try and compile this,
Okay.
but it will not work because
Not with the array list, right?
yeah, we didn't expect this to compile because if we didn't know exactly, I mean, if you know that this method has T, but then you want this T to be the same as the T of your thing.
Oh, I see.
So you want to be the same T as the class you define because you want to compare them. So, so this would just have a compare thing, but then when you come to implement this class, it wouldn't allow you to compare your thing with, because so these are the compatible types.
Also, now, I got a bit confused now. So, in what case do we use question mark exactly? Because
I think when the bounding, the bound type does not appear anywhere else, so you can actually anonymize in the sense. With some T that you don't use anywhere else, you can just put the question mark instead.
okay.
But in some signatures we couldn't do that because T appeared in several places. We also appeared inside the code, so then you can anonymize.
Oh, I see.
So is question mark different from writing object?
No, the question mark is different than writing T and then not using it anywhere else.
Okay.
So it's just for economy basically. In this case though, in this example, we also changed a bit the code in other ways. So we put priced object here.